time here. We are fortunate to have Brent Sheets with us. Brent has been here many times, and we're always glad to have you back, Brent. Thank you. Brent is now the director of the Petroleum Development Laboratories with the University of Alaska, operating under the initiative called Energy Research Consortium of Alaska. The Petroleum Development Laboratories unite disciplines across the university system that bring university research and company representatives together to allow University of Alaska to successfully identify and meet the oil industry research needs in the Arctic and beyond. And with that, Brent, I'm going to stop talking and let you have it.
I know, pretty much know everybody here anyway. Yeah. So not an issue, except how do I click? How do I move forward? There we are. All right, so that's our team that we're working with today. But I'm just going to cover three things that we're doing because these are the heavy oil research in particular, I think is a big deal for the North Slope. And then I'll touch briefly on the oil field infrastructure issue. And then I think coal gasification is going to be possibly a big deal for Fairbanks, but we'll see. So first, we'll just start with the heavy oil stuff. This is just kind of a depiction of the types of oil on the North Slope. So here you see the light oils. That's like water. That's what's being developed now. And over here, this is kind of a representation of the depth of these wells. They're about 8 to 10, 12,000 feet right in there. Then you move into the viscous oil, which is a little bit thicker, like syrup we say here. And the interesting thing about this, and then this UGNU, the future development, is like molasses, really heavy oil. The interesting stuff about the viscous and the heavy oils is that you drill right through those zones on your way down to the lighter oil. So these heavier oils haven't been produced because they're technically more challenging. In the lower 48, it's very easy to produce these heavy oils. You just introduce a whole lot of heat. You either introduce steam or hot water, any of those things. But on the North Slope, that's a bad idea. Heat is very expensive, first of all. And secondly, that heat will start to thaw the permafrost that's right alongside the well bores. And eventually what happens is when that permafrost melts, then that soil has no mechanical strength. And what happens then is that string collapses in on itself, and it becomes impossible to get tools down it and maintain things and to get oil out. And in fact, in some cases, the wellbore has been known to spring back into shape and then elevate itself like a spring and has sheared the top of the wells off inside their well houses. So that's actually an ongoing issue right now. And one of the oil companies has come to us to say, this is just an aside, not really part of my presentation, but it's such a fascinating issue to me. What they want to do is they see signs of this happening in some of their wells now. They're still producing wells. And so they've been talking to us about how to figure out a way to sort of, in a controlled fashion, knock it loose of that permafrost so the wells could spring back into place in a controlled fashion. And so we're maybe, acoustically going to shake it or something. I don't know. It's a very interesting problem. But the main point is, that we drill through these heavier oils. And so this is oil waiting to be tapped without roads, without new pads, without new infrastructure. It's just there. Sorry.
They don't have the problem about springing back in Texas, right?
Yeah, they don't have that problem in Texas.
So maybe Siberia.
Yep, right, yeah. Fascinating though, but that's why you don't want to put heat down these things. So we got to develop a technology that's non-thermally based.
Now, isn't the oil kind of warm coming up anyway?
Yeah, it is.
I was wondering.
And that's exactly why that's happening now.
So it's extra heat.
It's extra heat, yeah. But it's taken 30 or 40 years to reach that equilibrium because these wells are very well insulated. But ultimately, what's going to happen is that insulation is going to warm up ultimately anyway, just in 30 or 40 years for it to start happening. So there's actually 6 wells on the North Slope that are under orders by the AOGCC to be shut down right now because of this issue. And there's a whole lot more wells that this is on the way for. So it's really an interesting thing. But you could also, I don't know what else to do. It's not not my problem yet. I'd like it to be, because we might get paid to do something with it. But anyway, it was kind of fun. So anyway, of that heavier oil that we're talking about, the Schrader, or the Schrader Bluff wells in particular, there's about 10 to 12 billion barrels of that middle kind of viscous oil, and another 10 to 12 billion barrels of that super heavy oil. There's 20 to 25 billion barrels of oil just sitting there. Poor water flood mobility, I'll just kind of show you an example of what that might look like to sort of help you understand that a little bit. Can't use the heat due to permafrost, we talked about that. And this heavier oil is harder to transport, harder to treat. So we need to get it in the pipeline like today, while there's still that light oil that's a diluent. And I would argue that there's another reason to get that oil in the pipeline today. And I point this out to a lot of people. When I came here in 2002, Alaska provided 40% of the nation's oil. But with the improved technologies in the lower 48, we are now 5% of the nation's oil. Are we even relevant anymore? If TAPS reaches its mechanical or economic limit, anybody going to care? We're going to have all this stranded oil on the North Slope. So to me, it's more important and more relevant than ever to keep the oil production up in that pipeline, because if it ever goes down, would we have the incentive? Would we have the need to restart it? I don't know.
Well, we would, but on a national basis, would we?
We would, but the national basis might not, the demand might not be there. Yeah. There's a whole lot of stranded oil if that happens. So anyway, we're working with Hill Corp. They've been really generous with the university. And they have recognized that they need to invest in this university in order to have a resource base to go to for their research needs. Now, it wasn't Hill Corp that came to me with those other well issues. That was one of the long-term majors who's been here. But they are investing not only in our program, but all over the university. They have the biology department looking into things, you know, other engineering areas looking at pipelines, and they're engaging the whole university. And I will tell you, I'll just be very, very blunt. You know, they're also engaging some other universities. And so I asked Hill Corp, I said, so how come you're hiring New Mexico Tech or Missouri to do these other things? Basically, we're not there yet. I mean, we haven't done enough, at least in my area, in the petroleum area, we haven't done enough research to really get to those higher levels of research institutions. But we're on our way, and Hill Corp's committed to it. So,
what percent of Hill Corp's holdings are in Alaska?
I don't know, but it's a significant percentage. Yeah. It's, I don't know, does anybody else know off the top of their head? It's got to be at least 30%, if not more, of their holdings. Yeah. And you know, they have this deal with BP where they're Hill Corp and BP are joint owners on some of these units up there. And I was talking to BP, and they said they've never made so much money as farming it out to Hill Corp. They were very glad that they did it. And Hill Corp's a really interesting group to work with. I very much like that company. So anyway, this is kind of what the top one here is, just water flood. This is how they've been getting this heavy oil out, right? You just push a whole lot of water down into the well, into an injection well, and then you press against the oil, and then the oil comes up a producing well on the side. But what happens, because the water is light and this heavy oil is more like a syrup or a ketchup or something, you end up getting these channels of fingering. This is called fingering that comes through here. And ultimately, you get breakthrough, that water breakthrough. Now you just got a channel for that water that flows right up, and it flows right past the oil, and the oil stays there. That's what they've been doing, though. So we're using polymer, which makes this water thicker and heavier. And polymer is used in light oils in the lower 48. Nobody's ever used it on heavy oil before. So this is the first ever test of polymer and heavy oil to see how it works. And what makes this a research project is the fact that the Schrader Bluff and the Ugnu, those reservoirs are unconsolidated sands. It's just like a sandbox in there. It's not like rock, right? So when you're pushing this heavy polymer through that sand, you're going to you're going to have to use a lot of pressure, and you're going to probably end up producing a lot of sand with that, okay? So that's going to be an issue, but with that sand being so light, you could also cause harm to the reservoir because you get these wormholes occurring, or parts of the reservoir will collapse in on itself, the oil's displaced, and we're using higher pressures to inject this polymer because you have to, because it's a heavier polymer stuff. So we've been doing this pilot project on the North Slope in 2 wells, which I mean, if you think about it, they're risking several $100 million wells on this research project. So we've been injecting this for a year now. Our target is to hit 15% of the pore space with polymer. After 1 year, we're at 3% of the pore space, but we've caused no reservoir damage. So we've de-risked this method of injection, you know, with that unconsolidated sand. So just in the last year, E&I has started, we've been told informally, E&I hasn't made any official announcement, but we've been told that E&I is now injecting polymer on the heels of the success of this. So they believe it's going to work. ConocoPhillips is watching it carefully. I think they're going to start using it here after another year or so, if we can really demonstrate its uptick in production. This should be about 10 or 20% more efficient than just water alone. So
what are the consequences? Are there any consequences environmentally, structurally?
No, that's actually, polymer is a pretty environmentally friendly product. When you get the produced oil out, you do have to pull the polymer back out of the production stream, and then we just recycle it through the well for the most part. It's pretty expensive stuff, but a chunk of it stays down in the well and displaces the oil, and that's a good thing. We want that, but it's neutral, environmentally neutral, and we know that because it's been used on the light oils before in lower 48. It does cause some problems with water treatment equipment. It like starts to coat, if there's a hot pipe, that polymer will stick to the hot pipe and kind of make a Teflon surface, which then lowers the efficiency of the heat transfer. So we're working on that problem, but that's the only problem that we've encountered.
The polymers, are those big sacks that are going up?
Super sacks, yep. Sent up there in super sacks. And that polymer is made in Georgia, but because of the Jones Act, it's cheaper to buy it under a license from, I think we're getting it from Russia or China.
Oh,
can't tell. Drives me crazy.
Oh.
I looked at trying to manufacture this polymer. If this takes off on the North Slope, there's going to be demand, all kinds of demand for polymer. It would be great if we could manufacture it in the state, you know. So I had a couple of chemical engineering departments in other universities look at it for here, making it in Fairbanks, and I don't think we can justify it. It'd be like rebuilding a whole big refinery. I don't think we can do it. But
is it material that we have in the state, or is it something that we should?
Some would have to be shipped in, but most everything else is here. So I have this coal gasification project we'll talk about. So I was basically with coal gasification, you make a big long hydrocarbon chain, and theoretically you could slice and dice it into anything that you want. So I was looking to see if we could do it with that. I made it sound a lot easier than it is. So anyway, we kind of covered the heavy oil. I'm going to just move on to the infrastructure piece of it.
Actually, I did have one question before you leave the polymer. Is that anything licensed or patentable? What you're doing?
Oh, what we're doing? No, we're using a commercial product. So
the commercial process.
It's the methodology here is I don't know if you can patent the method of production. I don't know.
Yeah, you can.
Can?
So I just wondered about possible additional revenue stream to the university kind of thing.
Yeah.
It's already in the use elsewhere, so it's in the public domain.
Yeah.
Not patent, that process.
Well, yeah, I can't think that we're adding really any new invention on this.
You're just proving up.
We're proving it up, and actually, this polymer and this viscous oil is outperforming our models and outperforming the theory that goes behind it, and we don't know why. So we got to figure out why it's working better than anticipated. We don't know. It's a good problem. If you're going to have problems, those are the good problems to have. So there's going to be a whole lot of papers coming out of this project. So, I mean, even if we don't make revenue, I think and the other thing, I'll tell you the other thing about this, that project that I just described kind of put us up on the map. And so Louisiana State has contacted us for projects. Colorado School of Mine is partnering with us. I'm partnering with the University of North Dakota on a project right now, my alma mater. So, I mean, just the fact that we've had this success is breeding more success, and we're getting the program where we want it to be. And the other thing that I didn't mention on this is that Corp is so impressed with this particular process that we're going to try it on the UGNU, which is the really heavy oil. The last time anybody ever tried to develop the UGNU was, remember when BP was doing the CHOPS program? That was a big, they really heavily promoted it. Cold heavy oil production with sand. And in that process, you basically took a wellbore and you had essentially an auger in the middle of that wellbore, and you produced all the sand and everything with it. Irreparable damage to the reservoir. With our polymer flood, the reservoir stays in place, and if there's new technologies 30, 40 years from now to get after that remaining oil that's in place, you still have the reservoir formation in place to get after it. So ours is a lot less damaging for that. And we've actually went to the Department of Energy and asked for $10 million to go after the UGNU field. And what we would do in that case, because that's such a heavier oil than what we're even doing to the Schrader Bluff, is we would inject a solvent first, and then that solvent would kind of loosen up some of the oil, and then we'd have a slug of polymer, and then a slug of solvent, and a slug of polymer, and a slug of solvent. So hopefully that'll happen.
How would you deal with the heat? The heat capacity of the water is high, of course, and the more water you get, the more energy you're putting in the surface. So.
Don't know. Have to ask the Corp on that one. I don't know the answer to that. I don't know how they're. I don't know what the temperature of the injection water is. I imagine they're matching the reservoir temperature, but so.
Yeah, but I mean, with respect to the UGNU, I know that it's higher up.
Oh yeah, it's a lot colder oil.
Yeah.
Yeah, it's right at the base of the permafrost. It's much colder. Yeah. I don't know. I'd have to ask Corp on that. Operations aren't my thing. Yeah. Okay, so this is one of the projects that is being considered by BP and ConocoPhillips. The assumption is when you get to these older fields, you've got to start taking out these pads and remediate that area. So this is a satellite picture in 2006 of a remediated pad area where they had taken all the gravel off. And this is 2012 where they had made a lake. So the question is, do you want a lake on the north slope when you remediate these pads? Should you leave some gravel on these pads? If so, how much gravel should you leave on these pads? Because ultimately, when it's all said and done, you kind of want that pad to be ground level, right? But you disturb the permafrost, so you get thermal karsting. So just by virtue of having been there, you're creating a lake. So do you leave the pad there or not? And that is the question, and what are the long-term ramifications of it? So what, frankly, Conoco and BP have asked us for, and they are considering, this is not funded yet, they want us to help them develop a modeling tool for assisting them and the state regulators in determining whether it's beneficial to leave some of the gravel on that pad, and if so, help them determine the optimal thickness for doing that. That's a very expensive process to put this model together because of the field work and all the other things that go into it. So our specialty is looking at the satellite imagery and remote sensing aspects of it with some ground truthing there. But ultimately what this model will do is it'll help you determine how much gravel to leave and what that site's going to look like 100 years from now in the future. So is that going to be an unintended lake, or is it going to be a gravel pad, or what do you want? My view is that we should just take them all away. It all turns into lakes, and then our tourism business is going to be kayaking all over the North Slope, right? Never mind. Don't quote me on that. That's not a real
So, Brent, can you go back to that chart there? Can you define what is that graph? What's that?
All right. Well, this is a remediated pad, and this is a satellite image that, forgive me, this is way outside my area. And what this graph is doing is giving you the elevation profile of that line across the pad. So from a satellite image, you're measuring, these are in meters.
Meters, yes.
So you're going from, you know, tenths of a meters. You can read the elevation of that line from a satellite. I mean, it's incredible to me. So across the length of that pad, this is 150 meters. And if you were just to start here, let's just say that's 20 meters in, the elevation above sea level is 1.1 meters. And over here, it's halfway across, that would be, what, half a meter? So right there. So it's just amazing what you can get off these charts and graphs, and we want to turn that into a predictive model. So the thing that BP and Conoco are interested in is, of course, they want to, the way I view this model and the way I think most people are viewing this model is we would make it available under license agreement, and then the oil companies, the regulators would put in their own assumptions about future climate data. So, but what we would do is we would characterize the ground and the ice content, because all that has a big effect on the model.
So is that pad reclamation, or is that just fairware?
I believe that was a reclaimed pad. It's in my notes.
So then as a
But
result,
Jomo told me I can't have my speaker notes up.
so then as a result, that then what creates is, say, uneven.
It's just like if you were to go in your backyard and create a garden, right? I mean, some areas of that, it may be flat when you're done, but next year when you come back, it's not going to be flat. Yeah. So water runoff, things like that will all affect it. Yeah. Okay, so this brings us to, this is actually my pet project, the coal gasification project here, which, you know, this is largely the same presentation I think I gave about a year ago, but I'm just going to kind of wander through it here. So demonstrate a small-scale coal gasification to fuel a reciprocating engine as opposed to a turbine. There's differences which we can talk about. Cost-effective coal generating capacity for small applications. So we're talking 5 to 10 megawatts here. If you really want to get this out into the villages, it has to be like 2 megawatts, and that's years away. I mean, what we're doing now is a stretch. If we're going to try to do villages, it's even harder. And then we want to provide load following services to Golden Valley. I like to say this is coal enabling wind, because it addresses some of the GBEA issues. And then it's ideal for islanding systems, which is the big deal in the lower 48 right now. They want to have like hospitals or college campuses or military installations can be islanded from the grid and still need reliable power. This can certainly do that. And it can help with local jobs in the villages. So this is what makes this whole project possible. This is the old UAF power plant. And it doesn't go away when the new one comes online fully. People think it does. But what does happen is boilers 1 and 2, which are coal-fired boilers, are going to be taken out of service. Boiler number 3 is oil-fired. Boiler number 4 is either oil or natural gas, LNG natural gas. It's not dual fueled. You have to change the nozzle. It can be one or the other. They seldom use boiler number 4, but boiler number 3 gets used a lot, especially when it's cold. All of that makes high-pressure steam, which turns a turbine, which generates electricity for the university, but more importantly, it makes distribution steam, makes heat for college campuses. Now, this is the boiler turbine setup. We also have a 10 megawatt diesel generator down here that isn't used anymore because of the environmental considerations. And that is fired, as I said, on diesel fuel, just regular diesel fuel. And then we have a 24 megawatt intertie with Golden Valley. So power can go onto campus or off of campus through Golden Valley. That is our most expensive power there. This is our second most expensive power. This by far is the cheapest power. So under this coal gasification process, these 2 boilers would be removed and replaced with a gasifier. And that gasifier would make synthetic natural gas to run, which you could put through a diesel generator. And also it'll make pyrolysis liquids that you could put through the diesel generator. So we'd decommission the oil tank, we'd repurpose the oil generator, and we would replace the boilers with something that makes fuel for it. So this is just kind of a simple way of looking at it. We have the coal prep area, goes through the gasifier, ash drops out same sort of ash that we have now. All the systems are in place for all of these things. We just repurpose them. The gas would get cooled. It would run through an electrostatic precipitator to clean that gas, and it would also drop out the pyrolysis liquids, the oils and the tars. That oils and the tars would get blended with diesel fuel if it needs to be, but our test is too wrong. Our modeling suggests it's perfectly clean and fit to run through the diesel generator. The syngas would run through the diesel generator. We would recover the heat. The exhaust would go through a bag filter. We'd scrub it again with ESP, and it all meets the environmental PM 2.5 requirements. We ran into a problem with the manufacturer of the diesel generator when we were putting our proposal together. They said they'd be happy to commit resources to us to help with that. They changed their mind when they saw how much expensive it was going to be, and they don't really see a market for this outside of just a few applications. So we had to change our design a little bit. So we still have the coal, we still have the gasifier, the ash drops out, we have that gas cooling, the tars and liquids. That goes to the diesel generator, just as I said, but now we would have to blend it with the ultra-low sulfur because we have done something different with the syngas. So the gas goes through a scrubbing, a cleaning process, and it goes to a separate reciprocating engine that GE used to manufacture, but they've sold it now to Innu. I think I'm saying the company right. It's a Jan-Bacher machine, and Jan-Bacher machines work on low BTU gases. There's several of them in Anchorage running off of landfill gas. They're capturing their gas there. So that's our design. We now have a diesel generator and we're adding 2 Jan-Bachers. So why would we want to do this? Well, we just finished our feed study on March 31st. Our entire cost of the gasification and modifications to the plant, everything else, excuse me, came out to $46 million. That's everything in. That's the kitchen sink and the whole bit. We could probably cut $10 million off of this if we chose not to modify the Atkinson power plant and just built the plant on the side, because $6 million of this is just to decommission the boilers and take them out. And then there's another $2 or $3 million just to add structural supports to the floor to handle the new Jan-Bacher engines that we're going to put in there. So that's $6, $8, $10 million that we could, you know, you can build a really nice building for the same amount of money, you know. So, but we want to keep it in the same footprint. That's what it's going to cost, $46 million. So the feed study, coal going to the university is $4.50 an MMBTU. By the time we run it through our gasifier, pay off all the capital, pay off all the operating costs, the value of that syngas is $8 an MMBTU. Well, how does that compare to diesel fuel? I have GVEA estimated, but this price is not estimated. This is a real $18 an MMBTU for diesel fuel delivered to the university right now. $17 if we were to have natural gas there, 1520 to 2020 because of the numbers that Jomo put together there. So you can see that we still have a big margin here for our syngas, and that's after paying the capital and everything else. So Golden Valley, this is where we get into the estimated, and Golden Valley is not here, and I don't want to put words in their mouth, but we have looked at their numbers very carefully, and we, the university, have determined that it costs them $23.7 million to regulate wind. They were very generous to us. Golden Valley is a cost share member of this gasification project. They help pay for the feed study. They are excited about potentially being our customers, but I don't want to put words in their mouth, right? They gave us their books. These are our analysis, so I don't want anybody to hold Golden Valley to this, but it costs them, we think, $24 million to regulate wind out of Golden Valley. Using their term.
What does that mean?
So what does that mean? I'll hit that on the next slide. All right, we'll cover that on the next slide. But the bottom line is, if Golden Valley were to run their North Pole power plant, which is a turbine engine, at its regular loaded capacity, they could avoid this $23.7 million. They would have to pay us $11.8 million to regulate the wind. So it's not, this doesn't entirely go away, but it's the difference between these two, which is about $12 million in savings that could be realized.
So and that's the backup for the wind.
That's the backup for the wind. Yeah, that's the backup for the wind.
Is that annual cost?
That's an annual cost. That's an annual cost. Yeah. So, and this is just the university's cost to generate the electricity. It doesn't cover, there's no profit in that. But $12 million, you split it, you know, we could $3 million to the university to pay off the bonds for the new power plant, and Golden Valley would still save $9 million a year.
And that's the existing wind.
That's the existing.
If they double their wind, you could probably cover that and have even more savings.
Yeah, you could. Yeah, yeah. The payback for the university, if we go down this route, would be 4 years, less than 4 years. And you're generating. So this is what we're talking about with wind regulation. A friend of mine labeled this, instead I labeled it Eva Creek, he labeled it the problem. I didn't have the heart to do that. I don't think it's a problem. So what happens is that the wind is like all over the place, right? It's up, it's down. So you always have to keep a spinning reserve backup in case things happen. The only device in the Golden Valley fleet that's capable of moving up and down with any sort of speed is this turbine. It's an LM6000 turbine that they have, and they have other turbines too, but their biggest and their most efficient one is this one. And they can use this to regulate the wind. So if the wind's really cranking out, this turbine here is running at 5% load, 10% load, and I'll show you the efficiency curve. It's awful. It's absolutely awful, which is why it's so very expensive to regulate the wind. But you've got wind cranking out on the grid system. You have to have this turbine spinning, that's cranking out on the grid system. If you don't have that demand for the electricity, what do? You cut back on your coal, which is $4.50 an MMBTU, right? Your naphtha, your engine that they're running here, is about $17 an MMBTU. So you're using $17 MMBTU to regulate free wind, but you're curtailing your $4.50 fuel. So your costs are much higher than they would have to be.
So Brent, where does the solar panel?
It'll be the same thing. It's intermittent. It's intermittent. In fact, the curves on the solar are just like wind. Yeah.
But that's very small.
That's a very small amount, yeah, what they're talking about. But if it takes off, they're going to have issues. But I mean, already Golden Valley, I mean, you see it with the craft issues, right? I mean, Golden Valley is already pushing back on wind and any more intermittent sources because they're maxed out. They can't regulate. They don't have the resources to regulate this. And, you know, people think it's short-sighted of Golden Valley, but really these technology for these Arctic blades didn't even exist until like 2000. There was no reason to build your power system with wind regulation in mind. So they have wonderfully efficient tools. I mean, Golden Valley did a really good job in picking that LM6000, that turbine. It is so efficient, but they're using it the wrong way, and they've lost all the benefit of it. And they'll tell you, that's the reason we kind of started this is Golden Valley came to us and said, we need like 30 megawatts of reciprocating engines because it can follow this wind. And university, you have 10 megawatts. Can we have it? And we're sitting there saying, no, can't have it because we're too worried about the environmental regulations, you know. But we've shown with this study that we can turn that diesel generator on and still stick within the regulations. So anyway, the point of our project would be to start using a diesel generator, a reciprocating engine, in place of a turbine to regulate the wind. And since you're running it off of coal, that's still $8 an MMBTU as a syngas fuel. So it's still your cheapest fuel. And now you can start curtailing your most expensive assets. You don't have to use your most expensive assets in that way. So this is the efficiency curve that looks really, really busy, and I apologize, but this is a Golden Valley curve. I had a very simple cartoon, but they gave me, they put together this graph based on their own modeling and their own data. This is the efficiency curve of the turbine, their LM6000 turbine that they have. And so when Eva Creek, which has a capacity of around 27 megawatts, I think it's rated 25, but it's with our winds here and the density of our air, they get 27. When the Eva Creek is cranking out at 27 megawatts, right, at its highest level, the curve here, the turbine is running at maybe 7% load, right, or 7% efficiency, right, because the wind's got all of this. So they're running right over here at 10% efficiency, less than 10% efficiency. So 90% of their fuel is just going up in smoke. That's emissions, you know, they're not getting anything for it. So you compare that to a reciprocating engine at a low load, right? You're almost at 44% efficiency right there. So the goal is to get this machine turned off until right here, where it becomes more efficient than the diesel. And then you can see this is like 52% efficient at its peak. This is a beautiful machine. But the diesels can go all over the place. They can go up, down, boom, boom, boom. They don't care. They can take that beating, but a turbine can't. So they used to do scheduled maintenance on this turbine. With the way they're using it now, I think 3 times a year they're rebuilding the combustors, and every time they do that, it's $500,000. And I said, holy cow, that's a lot of money. And they said, that's nothing compared to the fuel we burn through it. That's a drop in the bucket compared to the fuel that they burn. So,
Because you don't brief this at the lefty.
well, maybe they will. I also have to tell people this is a research project, right? It sounds beautiful, but nobody has built a gasifier at this small level. Gasification units are commercial at the gigawatt level. And you need to have oxygen tanks, high pressure vessels. It's a whole big deal. We're stripping all of that away, and we are trying to make a small gasification unit that, to be honest, makes really crappy syngas. It's not good for anything other than burning as a fuel. You can't use it to make polymer. You can't use it to upgrade anything. It's only a good fuel. It's like 250 BTU per MCF. And normally it's like 1,000 BTU per MCF. So, I mean, it's a crappy syngas. Make no mistake about it. But
Germany in World War II made some sort of fuel out of coal.
Yeah, absolutely. Yeah.
You would add the Fischer-Tropsch reactor to the back end.
You would, yeah.
It's a catalyst that makes the hydrocarbon change.
And in fact, you know,
We have a big report on this.
Yeah, that's right. Yeah. So anyway, it's a research project. That's why it's not briefed yet, right? Let's build it. Let's prove it. Then we'll see what happens. So I think it's a good thing, but I don't want another Healy Clean Coal project.
I was going to say, how are we going to how are we going to fund it?
Oh, well, that's the exciting part. I'll come to that too. So this is the Onbacher machine, just to show you what they look like. This is a generator on the other end, but this burns really low BTU syngas. Western Energy Services, a company out of Anchorage, is the local vendor. They are willing to help us build this plant. So they would provide cost share. This plant's going to be $45 million. I said 46, $45 million. Department of Energy is really interested in this. So they would fund 80% of it. We have to come up with 20% of it. So we have to come up with $10 million. And sales of electricity can count towards our cost share. So as long as Golden Valley is willing to buy the electricity, and as long as the university is willing to go along with this project, and that's by no means decided yet, well, we've got money to be made. So
How's the emissions on something like that?
really good. We designed the whole thing around emissions because that was the key factor. This thing, in fact, I just got back from Pittsburgh where I was doing a project review meeting, and everybody was pretty impressed. And we spent a lot of time on emissions, which I didn't put these slides in here, but we designed it around emissions. So it was designed with that in mind. But it's also quite affordable. We compared it against just regular coal plants. This is, you know, not against other things, but if you're like at a 10 megawatt plant that you're going to build a new UAF or a new Aurora type thing, your efficiency for your coal and steam at a 10 megawatt level is, you know, right around 25%. We're at 30% lower heating value. Same thing down here, your capital costs. These are your total capital costs per kilowatt capacity. So 10 megawatts, your traditional coal plant is going to be about $17,000 per kilowatt just to build the plant. And we're talking, you know, less than that. This is a green field. This is like starting over from scratch with everything. It's cheaper than our plant because, again, our plant is, a lot of it's retrofitting our plant. So, just what I was saying, it's pretty radical what we're trying to do, make it work at this small level to fuel the diesel infrastructure that's already in place in many villages and in many homes, right? Ideally, we want to modularize it so it can be skid mounted, transported with just standard Conex box size skids, haul it out someplace where you need it, automate the heck out of it, plug it into your existing diesel generator that's also modular, bam, you got a power plant. So around Alaska, there's 37 villages that we know of are sitting on top of coal. Maybe they could dig their own coal someday. If you can't dig your own coal, you can deliver coal by river just like you deliver oil right now. And I think it's a whole lot environmentally safer, because if a barge breaks or a oil tank sitting alongside the Yukon River breaks, you got all those fish are going to die. If a coal barge tips over, the fish swim out of the way or they get a big headache, and that's the end of it, right? So, but that's, like I said, long ways away. So why is the Department of Energy interested in it? Because the large coal plants in the lower 48 are getting their butts kicked by natural gas. Partially because natural gas plants can follow the undulating grid that's down there. And as you get more and more wind farms in the lower 48, they're going to have the same problems that we are. Gas is certainly more attractive. We're already demonstrating that we can do our gasification cheaply. Well, I shouldn't say demonstrating, but we have shown through our feed study that we can do it cheaply, environmentally friendly. You take our system, put it at the interface of a traditional coal plant and the grid, and then that becomes a shock absorber. Because these big coal plants, their set points take a long time to change, but a coal, a syngas engine can change rapidly. So you put one of those at the interface of this coal plant, let it take the hits on the grid while the other plant takes its time to fall into place. And we could do the same thing with Healy 1. Aurora is very excited about this potential for their plant renewal. And so we got the whole coal burning community behind us on this. So how are we going to get it done?
Your environmental does presume Healy coal.
It does, yeah. It's all, it's all on Healy coal, or on Usabelli coal,
Yeah.
So we're tackling this in 3 phases, all right? So we just finished phase 1, March 31st, with our feed study. I'm putting the finishing touches on it now. I'm happy to, it's a public document once I turn it into DOE. So in fact, I've got it out to several people who are more environmentally minded than I am, maybe just for one good check, from their view. So Golden Valley's reviewing it. I sent it over to Aurora. I don't know if they're reviewing it, but I sent it over there. I've got it out to a few places, so I'm waiting. I'm very eagerly waiting to see what Golden Valley has to say about it. But Golden Valley provided $50,000 in cost share to do the feed study, so they weren't idle. Aurora provided some money for cost share, so they aren't idle on it. So we'll just have to see what happens. So we finished our feed study. Phase 2, I just turned in our continuation application to the Department of Energy. Under phase 2, so I should back up. Under phase 1, there were 8 to 10 awards, or 6 to 10, I can't read it under there, awards for people to just put their teams together, figure out the concept. Then DOE is going to down select to 4 or 5 teams from around the country towards a demonstration plant. Of those 4 to 5 down the road, we are the only ones that have our feed study done. So we have a real good head start on all these people. And my continuation application to these guys was over 500 pages of documentation, feed study, techno-economic analysis, you name it, we hit it. So I'm pretty optimistic that we'll be one of these 4 or 5 from around the nation because we're so far ahead. Assuming that we get that continuation award, it will begin in August. So I have from August of 2019 to August of 2020 to accomplish the following. I have to put together a business structure and raise $10 million in cost share. My hope, and so far nobody's laughed at me, is that the University of Alaska, Golden Valley maybe, Aurora maybe, Western Energy Services out of Anchorage maybe, would all form a limited liability corporation with the idea that we would be around for as long as this demonstration plant is, which is probably about 3 to 5 years, right? And at the end of 3 to 5 years, if it's making money, we just continue on. If it's not, we dismantle the assets, let Aurora take the piece, Western Energy take the piece, just take the assets away. So I have 1 year to put a business structure together, get $10 million of commitments, 1 year to get all the environmental permits in place so that we can construct this thing. And then theoretically 1 year to put the feed study together, but we got our feed study together. So the only two things I have to do is put a business plan together and get the thing permitted. And Department of Energy would pay us to do that. So then if we make it on to the third one, 2 awards nationwide for pilot plants, hopefully we'd be one of them, and then we'd start our construction. We'd go. So for basically $10 million, the university would get a $45 million plant that could make anywhere from $1 million to 12 million a year, depending on how it works out with Golden Valley and the power purchases.
That was my only question regarding those numbers you presented. You said 4-year payback. That's a 4-year payback.
Simple payback, yeah.
On just the $10 million, or on the full? Essentially, the project would pay itself back $40 million. In 40 years.
That means that we would, if we were, so basically we would, our cost of electricity is $12 million a year, right? So if we get reimbursed $12 million a year for that, and it costs us $45 million to make the plant, it's just, that's what it would be. So it's the whole project. Sorry, I had to think it through. It's been a long time since I put those numbers together. So it's just very simple payback. I mean, that's, you know, so so the risk factors, except for the gasification unit, we built this whole plant around commercially available technology. And our goal was to keep it cheap, and our goal was to make the results as repeatable as we can anywhere in the country that it's built. So that's why we relied on commercial components. So nothing new is being developed except the gasifier, and even the gasifier is based on a commercial gasifier that was used for 80 to 100 years called the Wellman-Galusha. If you remember the town gas reading in your history books, it was what made town gas. So you would have these Wellman-Galusha, which were very labor-intensive units, making syngas through a pipeline. London, New York, Boston, they all had them. It provided gas for your stove. It provided gas for your street lamps. So the HMI gasifier is largely based on that, with just a lot of modifications to make it more efficient and to make it a lot more labor saving. And as we said, emission controls is the key factor. So we think we've got that one cracked. And I will tell you that our environmental person at the university, when I first told her about this project, she laughed, said, "It'll never happen." And then she realized I wasn't joking, and then she got mad. And it was, hell no, you're never going to get this thing going. And a year later, she's a champion for this thing. She says, "Oh, we can do this. This is pretty cool." So we turned our, we answered all of her questions, you know. So and we had Dave Fish looking at it at Aurora, and Golden Valley's environmental person is looking at it now. So we're pretty confident we got it.
The expectation, emissions-wise, is technically, because of the following, you've cut net total emissions.
Net would be total. That's actually one of the things that I would like to see in this LLC, but I don't think Golden Valley would do it. I wouldn't if I were them. But I would ask that we all put our permits in that LLC so that we could trade off. You know, like you cut your emissions in North Pole, you get a little increase at the university.
Aurora would be interested.
Aurora, yeah, but if I were Golden Valley or any of these, or Aurora or anybody, I wouldn't want to put my assets, my permit things in there, because now they've got headroom, right? If they cut their emissions over there, they got headroom.
They're all facing their point source demand.
But mostly it'll be the appeal for Golden Valley. It'll be just to me the economics, but they've got to tell me if my economics are right? So we designed it with their system in mind. In fact, that could be part of the cost share too, is that we've already kind of had talks along those lines where they would, it'd probably cost $1 million to tie our syngas unit into the grid system and tie it in with their controls so that they have the driver's stick. You know, they aren't calling up the university, give me this, you
They
know.
might contribute that for the benefit.
That would be, that would be $1 million right there. If they would enter into a sales, a power purchase agreement, that would be helpful. I mean, if they join the LLC, that would be ideal. But, you know, I mean, these are all just ideas that I threw out at a table. And I would not want to mischaracterize that they are considering it.
But they're informed.
They're informed.
They just haven't done total due diligence.
Yep. I would never want anybody to leave this room thinking that this is an endorsement from Golden Valley or any of these groups, but they're informed and we're talking.
Brent, what's your technology for removing the sulfur dioxide from the thing?
I'll send you a copy of my feed study. It's largely ammonia, but I don't know what else we're going to do. I know that there's 2 or 3 technologies just aimed at the sulfur, and they hit at different points in the entire process. But got a question on oil? Sorry. Yeah.
So is there any consideration to the power plant of it clear? To utilize it in ways of,
I've never talked to anybody about that.
First things first is getting it together.
Get it going. Yeah, you know, I mean, it's just informally, some of the guys at Aurora are like, can't we just like do this demo at their plant? And we could. It'd be a plan B in my mind. My problem, it's not really a problem. It's having worked for the Department of Energy during the Healy clean coal days. I really want to manage expectations on this. I don't want people to think this is going to be the cat's meow until, I want to prove it. And I don't want to get expectations raised that this is going to be, the next greatest thing, only to have something happen where it fails. So if it works, think of how much better the second construction unit's going to be. It'll be a lot better. We're going to learn so much. Just getting the thing built and assembled, we're going to learn. I mean, those are tremendous data points. You don't want to be the first one to do something in a commercial application, in my view.
So regarding the coal, I'm assuming you'll be able to use the same coal handling as already being used in the existing plants. So it won't be that way.
Actually, yeah, we've got 2 day
probably
bins.
looking for those kind of efficiencies.
We are, yeah.
Okay.
Yeah. We're repurposing as much of the stuff that's there as we possibly can. And in fact, we've got 2 day bins inside there, one for each of those boilers, but we're only putting 1 gasifier in. So we're dedicating one of those bins for biomass in case we can use chips or like Bernie's wood pellet or paper pellets and things like that.
In the gasifier?
In the gasifier, yeah. So we've designed the gasifier to be fuel flexible to take up to 20% of that. The problem we had is in the environmental area with running those paper and cardboard pellet things. We just couldn't figure out how to address that environmentally, but we could probably use wood chips.
That's ironic. It's easier to clean up coal than paper.
We know a lot more. The use of belly coal has been well characterized. The paper and cardboard, you don't control what goes into it, and so you don't really know what the BTU value is, what's on it, or in it.
As far as like any chemicals.
We looked at it, and it was the analogy I'll use is like, you're outside a great big hangar door, and you think, oh, you're just going to go inside and see what's there, and you go in, and there's this vast space. So we're saying, okay, well, how do we permit these pellets? And it was just that. It was just it's just too big. It's too big of an issue, and it's too hard. I don't know how we could have done it.
It's big for a future day.
It's big for a future day, but but one of those bins is set aside for just something like that, whether it be wood chips or the paper pellets. Yeah.
Your gasifier, what kind of a technology are you going to use for that?
It's a moving bed.
Moving bed.
Yeah.
That's the problem with moving beds using organic materials because they have high potassium and sodium contents, and these things cause the agglomeration of the bed load. And so the coal is much safer to use than wood chips or pellets. This is a huge problem, agglomeration in these bio burning fuel plants or disposal plants. So I think that's a consideration to be thinking about is the potential for agglomeration. The
Actually,
university's having that problem right now.
yeah, I was gonna say, we've covered that already, yeah.
Well,
We're handling
it
that
is
with the
real.
temperatures.
Yeah, temperatures using pit run sand, thinking that that's appropriate instead of a commercial product. Just
You know what I always tell people about the Healy Clean Coal Project? The #1 thing we proved is that rocks don't burn.
Yeah, they can melt. That's what happens with research results. That's what happens with agglomeration is partly a melting.
Did you patent that? Cool.
Okay, that's
Any
it.
other questions for Brent before we let him go back and get this job done?
Yeah.
Okay, well, Brent, thank you for coming. We always appreciate you being here.
Always fun.
Yeah.
Is there anything about the lab itself we should put on record? Like, how long has it been up and running? I know you've got, multiple folks as far as like on staff, grad
Yeah,
students.
well, we don't have, so our staff, our research lab is staffed by grad students, and all the faculty, our teaching faculty, except me. I'm the only non-faculty person. My job is to find funding opportunities and raise money to keep everybody fed. I will say this, that our lab has wonderful equipment in it. I'll put it second to none. When I was with DOE, I funded a lot of projects there, so we made sure that it had lots of good equipment. And I would bring people up from DOE's national labs and give them a tour of the university's petroleum labs, and they would just salivate. There are no commercial labs in the state of Alaska to do the analysis that is needed for the North Slope, floor plugs, things like that. Even Fort Knox, Bailey was telling me that they could use stuff like that. My dream, and I've been talking to oil companies to make it happen, is for us to basically franchise our lab out, to bring in a Weatherford or some commercial lab. I don't want to take on commercial services because I don't think we can handle the liability or the control. But we got all the equipment that the commercial labs have. I would love it if a Weatherford or some commercial company would come to us, cut a deal where they use our labs, use our equipment. Local companies send all their samples there. The technicians that are employed by Weatherford or whoever the commercial lab company is take care of the samples, handle the samples. Students are wandering in and out. Students are seeing how all this works. Students learn. Maybe the university just collect a 5% royalty from the commercial company. We hang up a nice sign outside the duck green building that says commercial lab. I'd love to see something like that. It would generate money and it would make us relevant to the industry. Yeah.
So Brent, is that the difference between what you commented earlier for Mexico State versus UAF? You said we're just not there yet. So what's the difference between what New Mexico State's doing? We're not.
Well, they have, it mostly has to do with the expertise of their faculty. So their faculty are well-known in the industry, been around for ages. When you have an issue, you think of, in this case, Randy C, right? You think of him, so you go there. I mean, he's just well-known in the industry, and we haven't been around that long. I will also tell you, it's simply a matter of salary. These guys at New Mexico Tech and that, they make $280,000 a year, right? I mean, they don't make that. They're like me. It's research funded, right? But their hourly rate, $280,000 a year. Hourly rate here, $110. So we don't do anything to keep people here. I mean, it's the reality of it. I mean, I can tell you my colleagues doing what I do, 3 times as much money as I make.
We're glad you're here, Brent.
Yes.
If that helps, I mean. Brent, you have, did your, the petroleum, development lab, did it have anything to do with the, nuclear, seminar that was held in Anchorage a couple weeks ago?
No, that was Gwen, who will be here in a couple of weeks. She had something to do with that. But, my only claim to fame when I was at Department of Energy, we did the Galena nuclear studies. We're the first ones to do that. But I believe ASEP has a mandate from the legislature to keep up on that.
Okay.
Yeah,
Cool.
pretty exciting.
Cool. Okay. Well, thanks again.
Thank you.
Okay.
All right, next week we have Bud Fate. Week following, we have, Ms. Holman with ASEP. And now we have, the week following after that, we have Dr. Metz. So
All right.
All right. Little preview of our next couple of weeks, presentations.
Good news.
Thanks a million, Brent.
Here, you can turn off the recording.